Hello everyone, myself Vinay Kumaram. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. In my previous video, I was actually discussing the 10th chapter of 9th standard science subject that was on work and energy. So in my previous video, I have explained about work, and in this particular video, I'll be explaining about energy. So what do you mean by energy? So always remember, whenever you are using the word energy, how much amount of work is done depends on the capacity of a particular object to do that work. So that capacity of an object, capacity of an object to do work. So capacity of an object to do work can be known as energy. So that is the energy stored in that particular object, and when this particular object does the work on other object, then it is doing the work on other object and it is transferring its energy in the form of work to the other object. For example, if you are standing on a floor like this and there is a table in front of you. On this table, there is a book kept like this. What you will be doing is that you will take your hands and you will try to push this particular book in this direction. That means you are applying certain amount of force. Because you are applying certain amount of force, there will be some displacement happening to this particular book. So that means you are displacing the book by applying force on that particular book. So that means here, in order to generate that amount of force, so in order to generate this much amount of force, there must be energy stored in your hands. So only when you have certain amount of energy in your hands, with using that energy, you are generating force on other object and you are doing some work. So that means here you are object 1 and let's call this book as object 2. So that means here object 1 is putting certain amount of force on object 2 in order to displace that object 2. That means here object 1 is doing work on object 2. So that means here object 1 is doing work on object 2. So work has been done by object 1 on object 2. That means here there is energy transfer from object 1 to object 2. So energy is transferred from object 1 to object 2. Then did the object 2 got that particular energy? Yes, that object 2 has got the energy, hence it has displaced by this much amount of distance. So that means here the energy which this particular person is possessing in his hands, with that energy he is pushing the book forward. So that means here he is displacing the book. Why that displacement is happening? Here, because he has certain energy in his hands, with that energy he is putting force, and because he is putting force, there is displacement. So that means he is doing work with the energy. So that means energy is getting transferred from this particular object 1 to object 2. That means from the person to the book. Because the book is getting energy from that particular person, hence it is displacing by certain distance. So that means that book has been displaced from its initial position to certain other position. That means here there is transfer of energy from this particular person to the book. So that much amount of energy is transferring to the book. So that's why this book has got displaced by some certain amount of distance. So that means here work done is nothing but, energy. So in physics we always see that energy is related with work done, because here the energy which is stored in a particular object with that energy it does some work on another object. So that means there is interaction of both the objects where energy is getting transferred from one object to the other object. So that means here work has been done by the first object on second object. So that's why how much amount of work is done, that much amount of energy is lost by the first object and that much amount of energy is gained by the second object. So that's why work done is always equal to the amount of energy which has been spent to do that particular work done. So that's why in the initial explanation I told capacity of an object to do work is the amount of energy which that particular object has. So amount of energy or simply energy of any particular object is the capacity of that particular object to do work. So how much capacity that object possesses to do the work, that can be the amount of energy which that particular object is storing in it. So energy is also having SI unit as joule. So SI unit of energy is also equal to joule. So either you should write small j and expand the full form, or you should write the capital J and just write without expansion. So SI unit of energy is also equal to the SI unit of work done, that is joule. So our nature provides us the energy with different forms. So one is mechanical energy, the other is heat energy, the third one is chemical energy, fourth is electrical energy, and fifth is light energy. So that means heat also has certain amount of energy. So heat is also an energy, light is an energy, electricity is an energy, chemical reactions or any kind of nuclear interactions is also an energy. Mechanical energy is always there in our day-to-day life. So in mechanical energy, we have two different forms of energy, that is potential energy and kinetic energy. So inside mechanical energy, we have two different kinds of energy. So we will try to understand what do you mean by kinetic energy and what do you mean by potential energy in this particular chapter. So now, what do you mean by kinetic energy? So first let us look on to the kinetic energy. So what do you mean by kinetic energy? Kinetic energy is the energy which a particular body possesses when it is in motion. So always remember, if a particular body, if it is having certain amount of kinetic energy, then, so for example, if a car is moving with certain velocity v. So if this car is moving with certain velocity v, that means this particular car is in motion. So whenever a particular objects are in motion, so the amount of energy which they possess due to that motion, how much amount of energy it can possess. So due to this particular motion, how much amount of energy this particular car carries. So how much amount of energy is carried by this particular moving car due to its motion, that can be known as kinetic energy. So that can be known as kinetic energy. So always remember, any object which you see around you, whenever those objects are in motion, that particular motioned object, because of its motion, certain amount of energy it produces. So that energy can be known as kinetic energy. So now, how work done is related with kinetic energy. To understand that, we have to do some mathematical formulations so that we will get to a conclusion where how work done and kinetic energy or simply energy are related with each other. So now for example, we will take same car which is moving at certain speed. So let's say this is a car, and this car will be having certain uniform speed u. Now there is an acceleration in this particular car and it reaches its another velocity, the final velocity. So let's call that velocity as final velocity or final speed. So initial speed was u, and now after acceleration a coming into the picture, there is final speed v. And because of this acceleration, because of its gain in speed, there is certain amount of extra displacement happening, and that can be known as s. So this s is displacement, and this v is final speed, and u is initial speed, and a is the acceleration which is responsible for this particular car to reach speed v from speed u. So after understanding all these parameters, now we can define equations of motion on this particular car. So if we take the third equation of motion, that is v square minus u square is equal to 2as. So here acceleration is there, displacement is there. So now if you bring this particular 2a to LHS, then this 2a goes to the denominator. So v square minus u square divided by 2a is equal to s. So that means here s is equal to v square minus u square divided by 2a. So now we have got one equation for displacement. Let us call this equation as equation 1. So the equation for force is mass times acceleration, because here the car's speed has increased from its initial speed, that is u, to the final speed, that is v. That means acceleration has come into picture. So when acceleration comes into picture, that much amount of force is also coming into the picture. So that means certain amount of force is applied on the car. So here on this particular car, so the car which is moving with some speed u, on this car certain amount of force F is applied. When the force F is applied, immediately the initial speed u will be converted to the final speed v. That means its speed gets increased because of force applied on that particular car along the direction of motion. So for example, if car is moving in this particular direction, force is also applied in this particular direction. So that means speed of the car increases from u to v, and because speed is increasing, there is acceleration coming into the picture, because we are putting certain amount of force. That means driver who is sitting inside car, when he accelerates the car, that means he is putting certain amount of force on car by pressing acceleration pedal. So because of that force, car is getting accelerated. So that means here force is coming into picture and acceleration is also coming into picture. So that means force is equal to mass times acceleration. So this we can keep as equation 2. So now we have got equation 1, that is s is equal to v square minus u square by 2a, and we have got the equation 2, that is f is equal to mass times acceleration. So now since force is coming into the picture and there is extra displacement happening because of force coming into the picture, so that means there is certain amount of work done, and that work done can be given by this equation, that is w is equal to f into s. So f is the force and s is the displacement. So now we have two equations for displacement and force. So according to equation 2, force is nothing but mass times acceleration, and according to equation 1, we got displacement as v square minus u square divided by 2a. So we can substitute that v square minus u square divided by 2a. So here acceleration, both the acceleration which is there in numerator and denominator gets cancelled with each other. What will be remaining is 1 by 2 m into v square minus u square. So here you should not get confused. Whenever force is applied on an object, so for example, now car is moving, so that means car is in motion. So now car is in motion and certain amount of force is applied on this car. That means driver applies certain amount of acceleration, means he presses the acceleration pedal. So that means he is putting certain amount of force on this particular car. So because of this force, this particular car gets certain amount of acceleration. So when acceleration comes into picture, the speed changes from u to v. So that means there is change in speed. So when there is change in speed, there is an extra displacement coming into picture. That extra displacement, I am calling that as s. because of this force, this extra displacement is generated. So that means here work has been done, because here displacement and force are coming into picture. Because of this force there is an acceleration, and because of this acceleration there is change in speed. So because of change in speed there is a certain amount of displacement happening. So that means because of this force, this particular extra displacement is happening. So now because this force and extra displacement are coming into picture, there is certain amount of work done, and that work done is nothing but the extra energy which is gained by that particular car, and that energy is kinetic energy. And this particular work done is equal to the amount of energy possessed by that particular car when it got accelerated. So that means here when the car was in motion, it had some initial amount of kinetic energy. Now that particular kinetic energy has been changed. So for example, now we got this equation, work is equal to half mv square minus u square. So I'll just write that equation. So half m v square minus u square is there. So that means here if you now multiply half m with v square and u square, you will get equation as half m v square minus half m u square. That means here this is the initial amount of kinetic energy and this is the final kinetic energy, and this difference in kinetic energy is the work done which you are getting. So because of that much amount of force, you are generating this much amount of difference in kinetic energy. So that is equal to that much amount of work done. So that means here certain amount of force is applied on this car. So certain amount of force is applied on this car and its speed changes from u to v. So speed changes from u to v. That means it has gained the speed. So that means here acceleration is coming into picture. So that will give rise to an extra displacement S. So that means initially also this particular car was moving with certain amount of velocity. After acceleration, also this particular car is in motion only. So that means in both the cases, energy which is possessed by this car is kinetic energy. But here, because of this extra force is applied on this car, there is certain amount of acceleration coming into picture. Because of that, an extra displacement is occurring. So how much amount of displacement should have been happened because of the initial speed has increased. So more displacement has happened compared to the previous speed. When the speed is increased to v, that means here the displacement is happening more. So that extra displacement is accounted by this particular force, and that extra displacement we are calling as S. Because force and displacement coming into picture, there is certain amount of work is done, and that work done is equal to the difference in kinetic energy from its initial speed and from its final speed. So that means when car was traveling at speed u, so whenever this particular car was traveling by its initial speed u, and when this car was traveling at its final speed v, so here also car is in motion when it is traveling at speed u. Here also car is in motion when it is traveling at speed v. Because in both the cases it is in motion, here certain amount of kinetic energy is there, that is half mu square, and here also certain amount of kinetic energy is there, that is half mv square. So this kinetic energy and this kinetic energy, if you take difference of this, you will get work done. So if you take difference of these two kinetic energies, you will get the work done. So now we will take one particular case. So in this case, let us call initial speed of this particular vehicle or car is 0. That means u is equal to 0. So from its 0 velocity or from its 0 speed, it has gained some amount of speed. So that means here initial speed is 0 and some amount of final speed is there. So at that particular instance, W is equal to half m v square minus u square. This is the equation which we have got. So here u is 0. So this particular u becomes 0. So the only amount of work done is half mv square. So that means here directly work done is equal to the kinetic energy of this particular car. So this is how you should understand energy and work relation. So that means here W is certain amount of work done. That work done is coming because of the force which has been put on that particular car or any object. So certain amount of force on an object generates acceleration. Because of that acceleration there is change in speed. Because there is change in speed, there is certain amount of extra displacement, or in general displacement is happening. Because due to the force there is a displacement, there is work done. So here by the equation, by the help of mathematics, we have understood how work done is related to the energy. How work done is related to kinetic energy in this particular case. So that means now speed has increased. So the amount of kinetic energy will also increase at that particular point. So that means half mv square will be there. So half mv square minus half mv u square gives you the difference in kinetic energy. So the difference in kinetic energy, so that means that much amount of kinetic energy has increased. So there is difference in kinetic energy means that much amount of kinetic energy has increased, and that much amount of kinetic energy is increased because of the work done. So that means here when the fuel in car is burnt, that fuel, so here you should understand in this way. Whenever fuel in car burns, it releases some amount of energy. So whenever fuel is burnt, it releases certain amount of energy. Because this much amount of energy is released because of burning of fuel, that energy is responsible in doing the work. So that means that much amount of energy will generate work done. So that means whenever a particular driver presses acceleration pedal in his car, that means he is burning more fuel in order to get more energy, in order to get more work done. That means in order to get more force onto the car to travel at greater speed compared to its initial speed. So that means whenever a driver has to increase the speed of his car, he presses the acceleration pedal. When he presses the acceleration pedal, more fuel will be burnt, and that means more energy is released. Because of that extra energy, more work is done. Because more work is done, there is increase in kinetic energy. So that means here energy from fuel is transferred to the car. So that means energy from fuel is getting transferred to the car. So here you should understand energy which was there in fuel. So energy which was there in fuel is getting transformed to the energy of car. So here car is in motion. So that's why I'll call this as kinetic energy. So kinetic energy of car. So that means here when fuel is burnt, energy is released. And when energy is released, that energy gives rise to certain amount of work done. So that means here work done is happening. So that means certain amount of work is done by this car by receiving the energy from fuel. So initially car was standing at this particular position. Now car has come to this particular position. Let's imagine. So that means it has covered certain amount of displacement. Yes. So because it has covered that much amount of displacement, that means it has covered that displacement by getting force, and that force and displacement together gives the work done by that car, and that work done is happening because energy is getting released from the fuel. Because energy is released from the fuel, that force is applied on the car, and that car will move with by receiving that particular force, it moves by certain distance. That means displacement is happening. So when displacement is happening due to the force, work is done. So that work is done because the energy which was stored in the fuel has been transformed to the kinetic energy of that particular car. So that's why work done is related to energy. So always remember, work done is related to energy. So this is how you should try to understand work and energy. So the main concept which you are learning in this particular chapter is work and energy. So now if you are learning about work and energy, then you should be able to connect relation between work and energy. So first you should understand what is work, and using that work done, you should try to understand energy. So the capacity of a particular object to do certain amount of work, so that is its energy. So that's why work done is always related to the energy. This is all there in this particular video. Like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.